This video is about perfect squared trinomials. And before I begin this video, let me just make two quick disclaimers. The first is that as I make this, I'm a bit sick, so please forgive me if I'm coughing in the middle of the video. Second of all, we kind of previewed a little bit of this in class, so that's why some of this may seem like a repeat of what we did in class. Alright, so just be aware of that as we go through this. Alright, to start off, I would like you to factor these four trinomials. All right, remember the word factor, right? That means to rewrite them, right? Rewrite these expressions here as multiplication problems. Okay, so I want you to do that, and after you do that, I want you to think about this. 3 out of those 4 have something in common. I want you to think about what it is that those 3 have in common. Okay, so please pause and do that. Alright, so if you factor these correctly, here's what you should have gotten. For the first one, if you factor that, you should have x plus 4 times x plus 4. Oops, that should be a plus sign here. The second one, if you factor that, that should be x minus 3 times x minus 3. The third one, if you factor that, is x plus 6 times x minus 4. The fourth one, if you did this correctly, it is x minus 6 times x minus 6. Okay, and hopefully you also noticed that 3 out of those 4 have something in common. And I'm talking about 1, 2, and 4. Right? And what they have in common is that all 3 of those are what we call perfect square trinomials. Right? They're perfect squared trinomials. Okay, and what you should have noticed is that they both have the same factor twice, right? X plus 4 times x plus 4, x minus 3 times x minus 3, x minus 6 times x minus 6. All right, so why do we call that perfect squared trinomials? Right, well, let's think about this. We've used that kind of similar thing before. We've talked about perfect squares before. Right, what's a perfect square? Right, a perfect square is a number like 25. Why is 25 a perfect square? Because it can be rewritten as 5 squared. Right? 36 is a perfect square because it can be rewritten as 6 squared. Right? Or 144 is a perfect square because it can be written as 12 squared. Right? So 1, 2, and 4, these are perfect squares. Right? This is a perfect square trinomial because it could be rewritten as x plus 4 squared. Right? Something squared. Number 2, that's a perfect square, x squared minus 6x plus 9. That's a perfect square trinomial because it could be rewritten as x minus 3 squared. And same thing with number 4. That could be rewritten as x minus 6 squared. Okay? So obviously, not all trinomials fit this pattern, but there's certain special ones that are perfect square trinomials. Right? And this video is about that pattern. Okay, so I want you to take one more look at these 3. Hopefully you notice something in common, something special here, with related to this 8 and this 16, negative 6 and 9, and negative 12 and 36. Right, and here's the pattern. Right, think about 8. What's half of 8? 4. And if you square that, you would get 16. Negative 6. If you take half of that, you get negative 3. And you square negative 3, you get positive 9. How about negative 12? Well, half of that is negative 6. And if you square that, you get 36. Right? Hopefully you also notice half of 8 is 4. So this is x plus 4 squared. Half of negative 6 is negative 3. So this is negative 3 squared. Half of negative 12 is negative 6. So this is negative 6 squared. All right, let's see if you really got this pattern. All right, so let's say we want to continue this pattern. Right, and I have this trinomial here. X squared plus 10x plus some number here. Right, and we want to fill in this blank so that when we factor this, we'll get the same thing here. right? And then we'll be able to rewrite this as something squared, right? We want it to be a perfect square trinomial, right? Can you figure out what that number would be? Well, the answer is this number should be 25, right? It follows the same pattern as we had on the previous page, right? Think about it. 10 divided by 2, that's 5. And then if we square that, we get 25. Right? And so this would be, if you were to do your magic x plus 5 times x plus 5. All right? Or in other words, x plus 5 squared. Okay? Let me do one other one here. What would be in this blank? X squared minus 16 plus some blank. If we want this to follow the same pattern, well, this number would have to be 64. How do we get 64? Right? Well, negative 16, what's half of that? Negative 8. And if we square negative 8, we get 64. Right? That works, and it would follow this same pattern, right? We would get x minus 8 times x minus 8, which is the same thing as x minus 8 squared. All right, can you please pause the video and finish the last two? Follow that same pattern. All right, so here's the blanks. This one should be 100, right? 20 divided by 2 is 10. Square that, you get 100, right? So this is the same thing as x plus 10 times x plus 10, but you know what? I'm just going to write it as x plus 10 squared, right? Well, what the last one? The last one should be 49, right? Negative 14 divided by 2 is negative 7, and if you square that, you get 49, right? If we factor this, we could rewrite that as x minus 7 times x minus 7, or we could just write it as x minus 7 squared.